Although GoalSeek is very useful, it only allows for changing one input cell. That is very limiting. Also, there may be a number of other constraints that we want to take care of. A third-party company saw this need and developed another program written in VBA in Excel that solves it, called Solver. This was very powerful, and Excel decided they would like to have that available as part of their offerings, and so they bought the rights to it. It's actually distributed with Excel, but doesn't automatically become available unless you set it up. You can tell if you've got it set up or not if you look over here under Data, Analyze, Solver. If that's not showing, let's go set it up. We do that by clicking on File, Options, and Add-ins. This is an add-in. It's another sheet that sits behind our spreadsheet, but allows us to use all the VBA functions that they've created. This one is called Solver, so you'll click on Solver Add-in, and then go down to Excel Add-ins and click on Go. Notice up here, this was unclicked, so let me click on it and set that to being able to use. You'll have some other things that you may or may not have open and available as well, and then say OK. Hopefully you will see Solver available. Another way to do this would be to click on Developer, look at Excel Add-ins, and make sure that it's checked there as well. Just another way of checking it. Let's now go play with Solver. In this first example, we make potato chips, 5 different flavors. We want to optimize our profits by producing as many chips as possible, but we can't exceed our demand here. So we want to change these and figure out what combination will optimize our profits. When I look at a Solver spreadsheet, I often will put the Control tilde or look at formulas, view formulas, to see where the formulas are. You do not want to override any of the formulas because you can't just undo it. Next, let's bring up Solver. So Data, Solver. You'll see on this first one, I've already input the amounts for you. The set objective is B13. We're going to maximize that by changing cells B4 through F4. And we have some constraints. That is, B16 and 17 have to be less than D16 and 17. What does that mean? That's right, we can't use more than what we have available. This next constraint says B4 through F4 has to be less than or equal to B10 through F10. Our bags produced have to be less than or equal to demand. We make these non-negative and we'll say solve. Solver found a solution. All constraints and optimality conditions are satisfied. We'll say OK. It looks like we can earn $394.80. Notice we've run into the constraint of used and available. We've used all the labor available. To produce 200 regular chips, that's the total in demand. Wavy, 80 is demand on it, so we produced all we could of those 2 chips, and then the rest we put in producing barbecue chips. Having run into the constraint of labor, I have a real deal for you. You can get 500 more hours of labor for $500. Let's go to the next sheet. Here you will notice that we've input 1,500 hours of labor available. Go ahead and solve this one. Would you take the deal? Okay, let's take a look at this together. The same information, same constraints. Let's go ahead and solve it. Okay. And it looks like we'd have a profit of $487.59. So should we take it? It's more. You're right. We forgot to talk about the $500 charge. We put in the extra hours here of labor, but we would have to subtract $500 from this amount. So no, we better not take that deal. Another question that students often ask me is about what the solving method means. Normally, we'll use simplex. That solves anything we really want to, although nonlinear works well, especially if there's nonlinear equations involved. Evolutionary is something I enjoy talking about, as it involves some of the work I've done in my research background. As a professor at Carnegie Mellon University, I taught artificial intelligence. I also had joint PhD students with Herb Simon, the Nobel Prize laureate and the father of computing and artificial intelligence. One of our students was into genetic algorithms, which was brand new at the time. What it does is focus on putting out a large population of possible results, running one generation of them, combining the best, and then running another generation and so forth. Also introducing a bit of error along the way, or mutation. This was applied to the flow of oil pipelines and the problems involved with it. Another example was we had a machine at Carnegie Mellon that played poker extremely well. We set this poker playing machine against the genetic algorithm and let them play. At first, the genetic algorithm had no idea about the rules of poker, let alone how to win. But as the day progressed, it not only learned the rules of poker, but it learned the winning strategy to beat this particular machine rival. You would use this evolutionary method, which is another name for this genetic algorithm, when you have multiple hills to climb, and some may be lower and some higher over in another area. This way you're more likely to find that best result rather than end up at a lower hilltop. Let's try the next scenario. Here we resolve our potato chip dilemma by saying that we have to at least meet demand. We can make as many as we want, but we've got to at least have 100 bags of each. Go ahead and try that one. You'll notice this time around you have to enter the amounts. Go ahead and do it. What was your answer? How did you do? Let's work through this together. So data, solver, and our profit maximized by changing the number we make, and our constraints, and in this one we have to produce greater than or equal to the demand. Okay, we'll make our constraints non-negative so that we can click through and click through solve. What's this? Solver couldn't find a feasible solution. Did you click right through this without realizing that? Many people do, and they think that their profit is going to be $635. Here we've created 100 of each one of these bags, and we're way over labor and raw material. So no feasible solution. Always check for this. At least in this edition of Solver, you have a red exclamation mark to help bring it to your attention.